Today we are going to study about the properties of complex number system. In the previous class we have studied what is a polar form of a complex number system. Okay, so before going to start this class, I would like to tell you something like, yes, if you want to really understand the concept, then please do watch the entire video, and if you haven't subscribed already my channel, then please do subscribe, share with your friends as much as you want, and so that they can also understand. If they don't know the concept, then they will get to know my videos and I can explain them better, like maybe it will be helpful to them. Okay, so let's get down to the business. Let's start the class. Okay, and if you have any doubt, please do ask in the comment box. Don't forget that, and don't forget to hit the bell icon, because as soon as I upload the video, you will get the notification on your phone so that you can watch it. Thank you. So today we are going to learn about the algebra of complex number system. Okay, so we know that a complex number Z is, we can represent it into a real part and a imaginary part. Okay, so Z we can write as x plus iy. What is x? X is nothing but the real part of a complex number Z. Okay, so what I can write is real part of Z is equal to x and imaginary part of x is equal to Z is equal to y. So here Z is equal to x plus iy, and real part of Z is equal to x and imaginary part of Z is equal to y. So this is our, since this is a real axis, so in this direction our real distance x, and here is imaginary distance y. Okay, so we are going to verify this formulas. Z1 plus Z2, how these things will behave. Okay, suppose Z1 is equal to x1 plus iyy and Z2 is equal to x2 plus iyy2. Now we are going to add this. Okay, let's see what happens. Z1 plus Z2 is equal to x1 plus iy1. Instead of Z1, we are going to write x1 plus iy1, and instead of Z2, x2 plus iy2. Okay, so now when we are going to add these two complex number, we are going to add the real part of first complex number with the real part of second complex number. So then plus I into the imaginary part of first complex number with the imaginary part of second complex number. Okay, so x1 plus x2 plus I into y1 plus y2. So these things will become like this. Okay, so okay, let's check for the second property. The second algebra is Z1 minus Z2. It is the same as this addition, only in between now you can see that x1 minus x2, okay, the real part of the first complex number minus the real part of the second complex number plus the part of second complex number. So this is the answer. So these things will become nice. I hope you have understood it. Okay, so next Z1 into Z2, we know that Z2. So now we are going to multiply this Z1 and Z2. x1 plus iy1 into x2 plus iy2. So now you have to multiply. Okay, as the like normal multiplication. x1, x2, then x1 distributive property with this one x1 plus iy2. Okay, now we are done with this first term. Now go for the second term. Plus I into y1 into x2, so I into x2 y1 plus now I into y1 plus I into y2. So what is I into I? I into I is nothing but I square. I square is what? Minus 1. We have studied in the first class. So this is the minus 1 by 1. Okay. So now This is the real because it is independent of I. These are the independent of I. So we are going to bring these real parts to one side. Then this imaginary part into another side. Now we are done with the multiplication. Okay? So this things will become okay? I hope you have understood. We are done with this. Go for this part. Okay? This part. So check this one. Z1 is what is Z1? Z1 is x1 plus I1. Okay. Do is if I am going to multiply this term with x2 minus I y2 and divided by x2 minus I y2 without loss of generality. Okay, so it's the same term with the previous term. Okay, this is the same meaning. We have changed nothing. Just what we have done is we have multiplied x2 minus I y2 with x2 minus I y2. Okay, in numerator and denominator. So nothing changes here. So now this is a multiplication. It's usual multiplication. From this one we can multiply this one. x1, x2, x1, x2. I into I minus what? Minus I square. Minus I square is equal to 1. So plus y1 the real part. Then plus I into y1 x2 with minus I into what? x1 y2. Okay? Sorry. So now I is there. So take I common. So if you take common I, then this thing will become this. Okay? Then go for that. Then a plus b into a minus b. A plus b into a minus b, we know from algebra. A plus b into a minus b is equal to a square minus b square. So we are going to apply the formula here. x2 square plus I y2 square. So x2 square is x square minus I into y2 square. y2 square become y2 square become y2 square and I square become minus 1. So minus 1 plus minus 1 and minus is equal to plus. So these things will become like this. Okay? So this is our final answer. So z1 by z2 is equal to this is the answer. I hope you have understood it. Okay? So if you have any doubt, you can ask me in the comment box. Okay? Don't forget and just try it from your side and pause the video and try from your side. Okay? You just try on your own so that you can understand the concept better. Hello again. So we are going to study what is that property. Okay? So we are going to check one by one what exactly this property means. Okay? So here it is given z conjugate again conjugate. Okay, the conjugate of z. We know that z is equal to x plus iy. Okay, and the conjugate of z is this called the conjugate of z. That's z bar. X minus i. See, z is equal to x plus iy. Here z conjugate is equal to x minus iy. Instead of plus I, it becomes minus I. Okay. So here you can see z conjugate. What is z conjugate? Z conjugate is not equal to what? See, first this is our z. Z conjugate is x minus I y. Okay. So what if we do again conjugate? Conjugate of conjugate. So this will become x minus I y conjugate. X minus I y conjugate. So instead of this minus, it will become again minus minus plus. This is nothing but what? Our original z. So z conjugate of conjugate is equal to z. So we have proved the properties here. this is the property. So you are done with this one. Okay? Next. Z plus Z conjugate. Z plus Z conjugate. What is Z? Z is nothing but x plus iy. And Z conjugate is x minus iy plus x. So now we know, we have studied in the previous slide. Z plus Z conjugate is equal to the real part of first one with the real part of the second one conjugate. So this will become x plus x. Okay. Now this plus I into y minus y. And this y minus y will vanish. X plus x equal to 2x. So what is x exactly? X is nothing but the real part of z is equal to x. The real part of z is equal to x. So this is the real part of what? Z. So we can write like this also. Now we have proved this one. Z plus Z conjugate is equal to 2 into real part of z. Similarly, we can prove out this one also, imaginary. Instead of this plus, if I am going to do minus, okay? Minus, this thing will become what? Minus, and this one will become plus, because minus into minus plus. Okay? Now this x will vanish. So, this thing will become I into y plus y is equal to 2 what? 2y. Okay? So now this is 2 into I into y. What is y exactly? Y is nothing but the imaginary part of this y is an imaginary part of z. So we can write this. It's easy, right? Yeah, it's easy only. So now I'm going to check for this one. What's it? Z is Z conjugate. What is Z? X plus iy. What is Z conjugate? X minus iy. Now it's the same usual multiplication. Apply the distributive property. X minus iy plus iy. Okay? It's simple, right? We know all this, how to multiply this one. So x into x square minus I into xy plus I into xy, I into I square, but I into minus I square. Minus I square is nothing but what? Plus 1, because I square is equal to minus 1, minus into minus plus. So plus y into y square. Okay. So here the terms are there which is independent of I and dependent of I also. So what the independent of I terms are the real parts and the dependent of I parts are the imaginary parts. So what you are going to do is we are going to bring the real part one side and imaginary part the other side. So x square plus y square. We have brought this one, and these things will got cancel out each other because minus ixy plus ixy minus plus is equal to, they will vanish each other. Okay. So x square plus y square. What exactly is x square plus y square? X square plus y square is nothing but the distance from what? The distance from this is a this is x plus iy. So x plus iy. What is distance? This is y distance and this x distance. What is x square plus? You check this right angle triangle. This is x, this is y. This is the hypotenuse. So hypotenuse will be what? Root over of x square plus y square. But here is what? X square plus y square. This is nothing but what? Modulus. So we can write this distance also. Z is equal to x square plus y square. This one. Modulus, sorry, root over of x square plus y square. But if you are going to remove this one, so here it will become square. So z square is equal to x square plus y square. So instead of that, I can write. It's very simple, right? Yes, you can do it. If I can do it, you can do it. Okay, no problem. So z into z conjugate is equal to the mod of z square. Get done. Okay? We know z is equal to x plus iy. The real part of z is equal to what? X, and imaginary part of z is equal to The real part of x, the real part of z is equal to x, the imaginary part of z is equal to y. Okay? So now we check that. What is mod z? Mod z is nothing but from there, from the what you studied, x square plus y square root of. Okay? So here the real part of z, is what? Only x. So this x always less than or equal to mod z. It's nothing but x is always less than or equal to okay. The same case for y also. Yes, we are done now. Suppose we are going to give one example. 1 plus vi. This is the real part and this is the imaginary part. What is the real part? 1. Real part is 1. Here is 1. 1 is also less than or equal to. What is the mod z? 1 square plus 3 square. What? 9 plus 1 10. Root 10. The root 10. The value of root 10 is approximately it is more than 3. Okay. So basically this will become 1 into 3 point some terms. So definitely 3 is greater than 1. Okay. The same thing here. 3 is sorry. 3. This 3 is greater than 1. Again this 3 is always less than 3 point something. Okay. Because the value of root 10 is equal to 3 point something. This is irrational number. So 3 is rational number, which is we can see that this is strictly less than 3 point something. Okay, I get done.